Hello and welcome to another video in the graph series. Today's question is the last question of the kind of questions we have been doing so far in this series. In the next video, we'll be starting with a completely new topic. So make sure you watch this one. It's a slightly different question and it will make your thought process completely clear. Make sure you watch it till the end. Make sure you practice the question yourself. Without wasting any time, let's get started. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon. And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com. We have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. So this is the question. Surrounded regions. We are given an m by n matrix board containing X and O. So you can see there are X and O in this. Capture all regions that are 4 directionally surrounded by X. What does capturing mean? 4 directionally surrounded by X. Okay. So region is captured by flipping all zeros. So region is captured. So region must be consisting of zeros. Like for example, this is one region, this is another region. It is captured by flipping all the O's to X's. So we have flipped all the O's to X's. That is how we have captured the region. Now the question is, why didn't we capture this region? This is also O. Why didn't we flip this to X? Why didn't we capture this region? Because we have to capture the regions that are 4 directionally surrounded by X. It is very similar to the closed islands question. Here, is it given that outside the boundary it is all X? This is a question that you could be asking. If it would have been given, then this X, 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 and if there would have been an X outside, we would have captured this region also. But it is not given. This is a question that you can ask your interviewer. If it is on the boundary, what do we have to do? In this case, because it is LeetCode, the explanations are given. Here it is given. Notice that an O should not be flipped. So like this O is not flipped if it is on the border. So this is on the border, correct? So that is why it is not flipped. It is adjacent to an O that should not be flipped. And what does adjacent mean? Okay, now that is also very important. It doesn't mean like they might be connected diagonally. Because in that case, if this is connected diagonally, right? But we are still flipping it. We should not flip it if they are adjacent. Adjacent here means 4 directionally adjacent. Top, bottom, left, right. Again, these details, very, very important. These questions should be asked in an interview, might not be given to you. Interviewer might want to see that whether you are asking these questions or not. Okay, 4 directionally connected. So that means if there would have been an X down, then we would have flipped this. We are not flipping it because it is on the border. And we are not going to flip it if it is adjacent to an O that should not be flipped. Like for example, if this X was O, what do you think should be the output? The output would be exactly the same as this one. Our grid would not change at all. Our board would not change at all. Because then all of them, all the O's would be connected to an O that should not be flipped. This is on the border, correct? So note this again. If this was O, our board would not change at all, right? The bottom O is on the border, that is why it is not flipped. The other 3 are surrounded, form a surrounded region. Now what does that mean? So if you see this is surrounded by XX, this is also surrounded by XX, this is also surrounded by XX, right? The border of all of them are basically X. They are not leading to a boundary, right? This is very, very similar to closed island question, which we have already done. The link is in the description. It is part of the series. Make sure you're watching the series so that you don't miss it. This should become very, very easy. Now the key point over here is that we have to first go from the border. So we have to find all the O's that are there on the border. Make sure we somehow mark them as visited, or we make sure that we do not, flip them to X. How do I do that? Now, how do I know that which O should I flip, which O should I not flip? Think about it and let's get to the intuition now. This is the example that was given to us. This is another example that I have given. Just look at this example and tell me what should be the solution according to you. Here if we see, this is on border, this is connected to border, this is on border, these are connected to the border ones, right? Similarly, these are on border. So now this should also not be flipped, this should also not be flipped, this should also not be flipped. So the only O that should be flipped is this, right? Now how do we actually do this? Like for example, suppose I start from here and I start making these to X, like because it is on border, and then I will do DFS and I will flip it to X. The problem is that in the final solution, I want this to be O only. I do not want it to be X. So how do I do that? It is a bit tricky, right? Similarly, if we think over here, suppose I say that, you know what, I don't want to flip it. So I'm going to change it to X, like for example. So I've changed it to X. Now when I change it to X, I suppose do the DFS, or I change the other ones and I change this to basically X, X, X. Now all of them are X, right? But in the final solution, what do I want? I want this to be basically O only, not X. So how do I do that? Till now, what we have been doing is we always did DFS on the values that were there in between the matrix. Now, what if I do flood fill or DFS on the values that are there on the boundary? Listen to me very, very carefully. So basically, what am I going to do? I'm going to pick up all the O's that are there on the boundary, because those are not supposed to be flipped. Like I start from here, I see, okay, this is not supposed to be flipped. But instead of changing it to X, because I want it back to 0, I mark it as visited somehow. Suppose, for example, I change it to any other character. For example, I change it to say V or Z or 1 or anything at all. I mark it as suppose V, which stands for visited. Okay. Similarly, over here in this example also, I am doing it parallelly for this example also. I mark this as V. Similarly, all the ones that are connected to it, basically I do a flood fill or a basically recursive DFS, BFS, whatever you want. Whatever O's are connected to it, basically adjacent ones, 4 directionally, I'm going to convert those to V. Like for example, here I convert this to V. Similarly, this is on boundary. I'm going to convert this to V, convert this to V, convert this to V. Similarly, convert this to V, convert this to V. Any other ones that are supposed to be converted to V? No. So how does my matrix or my board look like right now? So it is basically X is X, V X, and this is this. Now whatever are the leftover O's, like for example, there is only one leftover O over here, which is this, right? I can convert this to what? I can now convert this to X. Saying that again, see the first thing that we did, whatever are not supposed to be converted, I did what? I converted into V. So this is how it looks like, XXX, VX, XXX, VX, again V, XX, XXX. This can be converted, so it's going to be O only, XX. So V are the ones that are not supposed to be flipped. Now whatever are the leftover O's, basically this can now be converted to X. So this has now become X. Now what do? We pick up all the V's, convert them back to O's. So whatever are the V's, basically just go through the entire board, convert them to basically what? Convert them to our O's. So this is what we wanted, right? This is our expected solution. So just that before conversion, what I am trying to do is somehow mark them as visited. By how am I marking them as visited? By marking them as V. So in this case, I marked it as V, right? Now whatever the leftover O's can be converted to what? Can be converted to X. Like this is going to get converted to X. This is going to get converted to X. This is going to get converted to X. Just rewriting it over here itself. So these have now become X. Now whatever are now V's can now be converted back to O. So this is our solution, right? Repeating it again, what we are essentially doing is going through the boundary, finding all the O's that are not supposed to be flipped and all the ones that are connected to it, adjacent to it, connected recursively by BFS, DFS, however you want to do it. In very easy terms, we are doing flood fill. Find all the O's, convert them to V, basically visited. Whatever are the leftover O's need to be converted to X. Leftover O's, we are converting them to X. Then whatever V we had, we are converting them back to O. Basically 3 steps. We are going to start writing the code. It should be completely clear. If it is not, dry run it. Once you dry run and see the code, it should be completely clear. This is very good. I hope all the basics are clear. Let's get started with the code now. We'll start with C++. Coming to the C++ code, as we had said, they are going to be basically 3 steps. The step 1 is basically to go through the boundary and adjacent ones, because it is given over here, right? Boundary or border, whatever you want to call it, border and the adjacent ones and the connected O's, and mark them as V or visited. Step 2 is that whatever are the leftover O's in the board, we are going to convert them or flip them to X. Step 3 is basically that now whatever V were there, basically flip V to whatever are there in the board, flip V back to your O, because that is how we have to return it. Correct? So these are the 3 steps that we have to do. In the starting, I need the dimensions of the board. So it is given m by n. So let me just find the number of rows, number of columns. Coming to step 1, we have to go through the border. So there are basically 4 borders over here, right? So we have to go through them one by one. So let's see if I first go through the columns. Basically this is like this, the top and the bottom one, right? So there my j or my the column number is going to be varying, right? J equal to 0, j less than n, j plus plus. And there are 2 rows that need to be dealt with. Basically the 0th row and the which row? The m minus 1th row. So what am I going to do over here is, if board of what? Basically I am talking about the 0th row right now. So 0 and j, if it is equal to O, then what do I need to do? I need to mark it as visited. I need to mark it as V and all the connected ones also. So I basically need to do either DFS or BFS. In very simple terms, I need to do flood fill. Now this you could either do DFS, BFS, we have already discussed earlier as well. We will be doing DFS in this solution. So in flood fill, what all things do I need to pass? I need to pass my row, my column, what is my size, basically m and n, and the board itself. So we have done for the 0th row. Similarly, we need to do for the last row also. And how do I check that? That if board of basically m minus 1 and j is equal to O, then what do I need to do? I again need to do a flood fill, because for all the connected ones as well, right? So m minus 1, j, mn, and then the board. So I am done with the top row, the last row. Similarly, I need to deal with the 0th column and the last column, right? So now in that case, what will be varying? My row numbers. So int I equal to 0, I is less than. So let's start with the 0th column. So if board of I and 0 is equal to O, in that case, what will I do? Same thing, just what is changing? Ij is changing. In this case, I is there, j is always 0, mn and board. Similarly, for the last column, so board of I is going to change, and what is my last column? N minus 1. If it is equal to O, I am again going to do flood fill, and my I value is going to be this, j is n minus 1, mn and board. So we are done with step 1. We will write the function for flood fill, don't worry about it. What is step 2? Whatever are the leftover O's. For the leftover O's, we don't need to do any traversal or anything. We can just go through the entire board. Now whatever are the leftover O's, basically we are going through the entire board. What am I doing? If my board of Ij, if it is equal to O, I just need to convert it to X, right? I just need to flip it back to X. So Ij is equal to X, that's it. And similarly, same thing we are going to do over here. But now what is happening is, what are we flipping? We are flipping all the V's to all the O's. And that's it, we are actually done. All we need to do is just implement this flood fill algorithm, which we have already done. So we'll quickly do it, but we are actually done with the question. Coming to writing the function, do I need to return anything? No, right? I just need to mark the O's to visited. So I'm not returning anything, just calling it flood fill, and I need to pass what all things? The row, the column, the size, so basically m and n, and the board itself. So in C++, again, remember, we have to pass everything by reference. I keep saying it, so I hope you are not making these mistakes again and again. So what is the main processing that I need to do in this flood fill? I need to mark it as visited. How am I marking it as visited? By marking it as V. Make sure whatever you are checking, that is the thing that you are actually marking also, right? Otherwise, it will all lead to, it will not work. Make sure that whatever you're checking with that is exactly what you're marking it with, obviously, for the whole thing to work. So here we are marking it as V. You could have marked it as anything. You could have marked it as 1. You could have marked it as S, M, N, anything you want. Okay, so here what am I doing is board of R and C, I am going to mark it as V, which is visited. And now what do I need to do? I need to go to all the connected zeros as well, right? How do I do that? I need to go to the 4 directions. And how do I do that? I'm going to use the vector. We have done this crazy number of times and I hope you are not going to make any mistakes now. I'm just going to go through all the 4 directions. And what am I going to do? I'm going to find the new row, the new column that I'm going to consider. How am I going to get that? Direction of k is basically 2 numbers and 0 is the one that is going to be for the row. And similarly, the new column is going to be that in the column, what value am I adding? I am adding direction of k and 1. So I have new row, new column. I need to call the flood fill again. What are the 2 conditions? Firstly, it should be safe to go over there, right? The new row, new column should be within the bounds. We have done this so many times that if I do this, I should not go out of bounds. So I'm going to write new function is safe. And what all things do I need to pass? I need to pass the new row, the new column, and the M and N. That's it, right? And if it is safe and the value over there is O, only then, right? So in this board, if the value at new row and new column that we have come across, if that is equal to O, only then what do I need to do? I need to do the flood fill again. We are doing DFS over here. You could have done BFS as well. You can try writing the code. We have done this in the previous videos. I hope you are completely clear with all of this. And the flood fill, I'm going to pass new R, new C, M, N, and the board. That's it. Let's quickly write this is safe function. It is supposed to return a Boolean. And these are all integer values. And what am I going to return? The R value should be within the bounds, so it should be greater than or equal to 0 and it should be less than M. And similarly, C should be greater than or equal to 0. Guys, be careful of small details. Like here, I have taken M by N. In some videos, we'll take N by M. So make sure you see that what you have taken, because it was given M by N, I've taken M by N. So make sure you see properly, you notice these small things. We're actually done with the code. Let's try running it and see. I hope I have done no mistakes. Okay, I did one mistake. Let's try running it and see. This works. Let's submit it and see. So yes, we passed all the test cases. Very good. I hope you understood the question very well. This was the last question of its kind, and tomorrow we're going to start with a new concept. So make sure you show up. Let me know in the comments that you understood the question, that you have tried it yourself. If you have any doubts, I'm here to help you out. See you next time, and let's get started with Java. Coming to the Java code, we are just given a board. We discuss about 3 steps, right? So let's note them down. What is step 1? We have to first find that whatever are the O's on the border, right? So whatever are the O's on the border and whatever are the adjacent ones, basically, and the connected ones. All the border and the connected what? All the connected O's. So whatever border and the connected O's are there, we are going to flip them or mark them as visited or mark them as V. Okay, that is step 1. Step 2 is what? Step 2 is that whatever are the leftover O's in the entire board, we are going to do what? We are going to convert them or flip them to X, right? So whatever are the leftover O's, because whatever O's need not be converted, we have already marked them as V. Now whatever are leftover O's, we are flipping them to X. Now we are done with flipping whatever had to be flipped to X. So in this step, the last step, whatever V's are there, we are going to flip all the V's to basically O, back to O. So these need not be changed. So we had marked them as V, we are flipping them back to O. So there are 3 steps. Let's start with finding the dimensions. So here it is given M by N, so I'm using the same notation. Now that we have the dimensions, we can get started with the step 1. The step 1 is to go through the border. So there are basically 4 borders, right? So there is top row, bottom row, there is the leftmost column and the rightmost column. So let's start with the rows first. So here the columns will be changing because the row is constant, right? So our basically J will be changing from where to where? From 0 to N. Now let's deal with the 0th row first. So what is the 0th row? So if board of, so the row number is going to be 0, j is going to be vary, and only if the value is basically O, only if the value is O, we need to go to all the connected ones also. So what do we need to do? We need to do a flat fill. We can do either BFS, TFS, whatever you want. We need to do a flat fill and we need to pass the value of row column. So row is 0, j, and then mn, basically the dimensions and the board itself. So we are done with the 0th row. Similarly, we need to do it for the last row. So what does the last row look like? So it is basically m minus 1 and j. Again, if it is equal to O, what am I going to do? I'm going to do flat fill for basically m minus 1, j, m, n, and board. So we are done with both the rows now. Now we need to deal with both the columns. So what is going to be varying in the columns? The I, basically the row number is going to be changing. So I equal to 0, I less than m, I plus plus. How do we find the columns? So basically if board of I is varying, the 0th column, so basically 0, if it is equal to O, then what are we going to do? We are going to do flat fill for I, 0, m, n, and board. Similarly, for board of I is going to be varying, and how does my last column look like? N minus 1. So if that is equal to O, again I am going to do flat fill, but now for I and n minus 1, I am again going to pass mn and board. So I am now done with step 1. I have done flat fill for all the O's that need not be converted. I have marked them as V. That is what I will be doing in this flat fill. In my step 2 and 3, I do not need to do any traversal. I just need to find all the O's and all the V's. Like over here, I need to find all the leftover O's. How can I do that? Just traverse through the entire board. So I equal to 0, I less than m, I plus plus. Similarly, so I'll be going through the entire board and checking that whatever are the leftover O's, so board of ij, if it is equal to O, basically what am I doing? I'm going to flip them to x. I'm going to change them to x. So that is where I'm doing this actual conversion. I'm capturing the region, right? So here I'm converting board of ij to basically x. And that is the exact same thing that I have to do in the step 3 also. The only thing is that if it was basically V, then I am going to flip it back to O, because that is what I have to return. So we are actually done with the code. All we have to do is quickly write this function flat fill. Now you could do it using DFS or BFS. We'll be doing using DFS. Let's quickly finish this. So quickly writing the function, it is private. Do I need to return anything? No, right? I just need to mark them as visited. So marking them as visited, copying this flat fill. What all things do I need to pass? I need to pass the row, the column, the dimensions, so m and n, and the board itself, which is basically given to us. Now what is the main thing that I have to do, main processing that I have to do? I have to mark them as visited. How do I mark it as visited? Here we have checked for V, right? So what you could have marked it literally anything. You could have marked it X, Y, Z, 1, 2, anything you want. I am marking it as V. So make sure that whatever you are checking and whatever you are marking is exactly the same thing. So please make sure of these little details. And also small things, right guys? Like here I have taken m by n because it was given to us. In some questions it is given n by m. So make sure you notice these small things. Make sure you write accordingly and you don't make these small mistakes. And that is why it is very important that you try writing the code yourself. Okay, now I have marked it as visited. What do I need to do? I need to go through its 4 neighbors. How do I do that? We have done this a million times now. I just need a 2D array. Going through all the 4 directions, so k equal to 0, k less than 4, k plus plus, and we are going to find the new row and the new column now, right? So new row is going to become what? Row plus direction of k and 0. Similarly, new column what? It is going to become column plus direction of k and 1. So we have the new row and the new column. What are the 2 things that we need to check? We need to check whether it is safe to go there or not, because it can be out of bounds. We have done this so many times, guys. Now I hope you will not miss these points and you will not make these mistakes. If it is safe to go over there, and when are we converting to V? Only when the adjacent ones are also what? It is O. So I have to check again that if the board of this new row and new column, if it is equal to O, only then what will I do? I will do the flat fill again. And what will be my new row, new column now? New R and new C. And I will pass the rest of the things as the same thing. We are almost done. We just need to quickly write this is safe function. So let's do that. Again, private, we need to return boolean, and is safe. What do I need to pass? The row, the column, and the dimensions. How do I check that it should be within bounds or not? R should be greater than or equal to 0. It should be less than M. Similarly, C should be greater than or equal to 0, and it should be less than N. Let's try running the code and see whether it works or not. So yes, let's submit and see. Great, we have passed all the test cases. I hope this was completely clear. If you have any questions, let me know. Otherwise, just mark it as you have understood the question. Let me know in the comments. Let me know if you tried the question yourself or not. It would mean just so much to me. I would know that you're following the series and it is helpful. And tomorrow we'll be starting with a new concept. So make sure you show up. See you next time.